Hello, my dear students. I hope you are all doing well. Good. So, today we'll continue with our lessons on functions. And this lesson is lesson number 3, functions. And our objectives are domain and range. So by the end of the lesson, each student will be able to identify the limits of a function. So the domain as one limit and the range as another limit. Good. So what we have here, so this is the system of a function. So let's consider a function as a system of machine. Okay. All right. So every machine has limits on what it can process. Every machine has a limit on what it can process. So a function is a machine. One input maps to one output. But if a button is broken, if pressing, let's say, button 5 causes the machine to fail, that input is excluded. Okay, so we are talking about input that will produce an output. So every input that has a corresponding allowed output is considered a domain or an element of the domain. Now, if there's an input which produces an element as an output which is not allowed to be part of that set, we say that, or we can exclude that element. Okay, so what I am trying to drive at is that a domain must surely produce an output. Good. So the complete set of buttons that work. So for example, if I have 1, 2, 3, and there's some kind of mapping, so let's say maps to 1, 4, and 9. Okay, because every single input produces an output, we call the left side the domain and the right side the range. Every single element in the domain produces an element in the other set, and so we call the first set domain and the second set range. Okay, Now, define the system boundaries, input versus output. What is it? What is it? We are considering our functions as a machine. Now, the input is whatever information you put into the machine. You calculate, you resolve it, what comes out becomes the output. Okay, so the domain is the input, the set of all x values, okay, for which f of x is defined. So remember that we say when you divide a function, an expression of a function, let's say 16 divided by 0, because we are dividing by 0, we consider this expression undefined. So as long as the denominator of that expression, the function, is not 0, okay, then all the values that to produce non-zero or non-defined elements, we call them the domain. Okay, so we come to the other side, which is the range. The range is the output, the set of all y values that the function actually produce from those allowed inputs. So if we put in 1 and we produces another 1, we put in 2, we produces 4, we put in 3, we produce 9, we are saying that because every element here produces its own output, and every output here is as a result of an input, we call the set 1, 4, 9, and a range set, okay, or a set of range. Good. All right, so we want to come here and we identify what can make a function undefined. What makes a function undefined? So we have a polynomial, we have a rational number, and we have a radical. Okay, so when we come to the polynomial, for example, x squared plus 3 or 2x minus 1, we are saying that nothing breaks it. Nothing breaks it. No value of x, okay, can make this function undefined. The system is completely unrestricted. All real numbers, okay, every number you put in place of x will give you another rational number, another real number. Okay, good. Then we come to rational. Now when we talk about rational, we talk about fractions. So for example, p of x divided by k of x. Now if the x value you put in makes the q of x equal 0, we say that the function is undefined. That is why we say that if we are dividing p of x by 0, if we resolve the q of x and the answer is 0, we say that that breaks the system. And so for a rational function to be defined, the denominator should not be 0. Good. Domain root. So set the denominator, which is q of x, to 0. Solve for x and exclude that values. We will get to work them and you know how it is done. Okay, good. So every value of x that will make q of x to be 0 is excluded. We are trying to say that those numbers will cause the system to break up. All right, then we come to radicals. Radicals, that is the square functions found under square roots. Okay, a negative number under the square root breaks it. A negative number. So we equate p of x must be greater than or equal to 0. The p of x must be greater than or equal to 0. Okay, so if you want to find out the domain, the numbers, the sets of number that will break this system, that will make the system undefined, then you have to equate p of x to be greater than or equal to 0. Then you solve for it. Then you can exclude those numbers as undefined. Thank you. All right. So we want to see how we can write the limits. So for example, we want to see which set. We want to learn how to write the set that breaks the system. Okay, good. So this is a common mathematical expression, and it is read as x is such that x is a member of real numbers, comma, x is not equal to 5. Okay, so always use this sign not equal to symbol for exclusion. All right, we want to write a notation. We found out that if x is equal to 5, a function will be undefined. Okay, if we put 5 into the function, the answer will be 0. So for a rational function, we are saying that 5 will break the system. And so how do we write this? Okay, in notation form. So we can just use words to describe it and say that the function is defined for all real numbers except 5. And we can use this notation to mean the same thing. We are saying that x is such that x is a member of all real numbers. Every number in all real number can satisfy the equation, can make the equation defined, except when x is 5. So x should not be equal to 5. Thank you. All right. So we come back to polynomial functions. Polynomial functions. Now, functions that are unrestricted. We are trying to say that every value of the domain will give you an allowable output. Okay, a range. Good. So we are saying that polynomials and linear functions are completely generous. When we say linear function, okay, good. This is a function which has the power of x to be 1, the power of x to be 1, or the power of the variable, the highest power of the variable is 1. Okay, and we are saying that they accept all real inputs. So for example, f of x is equal to 2x minus 3. Now choose any number you put in place of the x. When you resolve this, the answer you get will still be a real number. Okay, so for example, let's say x is equal to -5. So 2 times -5 is -10 minus 3. We have -13. And -13 is a real number. So we said that every value of x belongs to real number. Okay, it's a member of real, it's a real number. Every value of x we put into this function, the answer we get will be a real number. Good. Now we come to the range. Okay, how do you find the range of a function? Good. All right. Now you see that we have f of x is equal to 2x minus 3. In our previous videos lessons, we talked about the fact that y is equal to f of x, or y is the same as f of x. Okay, so we are taking away the f of x and we are replacing it with y. So the same equation, the same function, y is equal to 2x minus 3. Okay, you know that for a domain, we make y the subject. So the f of x is equal to, this f of x is equal to y. So for a domain, we make y the subject. But for a range, if you want to find the range of this function, then we will have to make x the subject. Okay, so we move with 1 to make x the subject, and we get x is equal to y plus 3 into brackets, all divided by 2. Y plus 3 all divided by 2. Now the fraction is defined for all real numbers. Why? Why? Look at where y is. Y is up here. So let's say we have y plus 3 all divided by 2. Every value you put in place of this y will give you a real number. Okay, put 0 there, put 1 billion there, put -55 there. Every single value, every real number you put here will produce another real number. And so we say that y is said that y is a member of real numbers. Okay, so for domain, we talk about the x. You make y the subject, and we speak about the independent variable. For range, we talk about the y. Okay, good, because the y here becomes the independent variable because we're making x the subject. So for range, we make x the subject. For domain, we make y the subject. So if you are given a domain, you can find the range. If you are given a range, you can find its domain. Okay. All right. So we come to rational functions. Okay. We are talking about the fact that when the denominator of a rational function is equal to 0, when you solve and the answer you get is 0, it makes the function undefined. So you want to see what breaks it. All right, good. So here we are given a rational function. F of m is equal to 2m plus 5 m squared, all divided by m squared plus m minus 12. Good. Now, this is a quadratic expression. All right, so what do you do? If the denominator is equal to 0, the function will be undefined. Okay, so if you want to find at what point, or if you want to find the domain of the function of m, we have to equate the denominator to 0. Okay, good. You have learned about how do you call it? We have done binomial expansion. Okay, yeah, so we can easily write out the values for this. Okay, so how do you do it? This is a quadratic equation, expression, now an equation. So we want to find the factors. Okay, good. So when you work it out, we have the factors are m minus 3, m plus 4. How do you do it? Now you multiply the coefficient of m squared is 1. Okay, the coefficient, the number in front of the m squared is 1. You multiply it first by the constant figure, which is times negative 12. So our answer is, negative 12. Good. Now we are going to compare the m and the negative 12. Please remember, when we are trying to find the expression, we said that the sum of the factors and the product of the factors. If you remember, when we had a plus b plus or minus 2 roots ab. Okay, so a plus b gives us the sum, and a times b gives us the product. So we ask ourselves, we have 1m here and we have 12. We pick two numbers. When we add them, we get positive 1m, positive m. Okay, when you multiply, we get negative 12. So we will choose negative 3 and 4. If I add negative 3 and positive 4, I get positive 1. If I multiply, I get 12. And so what do I write? My new equation will be m squared plus, now I have 4m minus 3m minus 12. Okay, so if I put this in bracket and I factor the m out, this is what we get. Okay, so I'm going to equate each of the factor to 0. So if I do that, m will be equal to 3 and m will be equal to negative 4. We are saying that if you put 3 in this equation, the answer will be 0. If I put negative 4 in this equation, the answer will be 0. So therefore, if I'm looking for all the numbers in the world that will make this function define, that will produce an allowable output, then those numbers should not be 3 and negative 4. They should not be 3. That's why I said m is not equal to 3. M is not equal to negative 4. Because if I put 3 inside, the answer will be 0. If I put 4 inside, the answer will be 0. Good. So we want to run through how to find the range of a function. Good. So to find the range, our function machine must go the other way around. Okay. So now this is our function. And this function will produce our domain. Good. If we want the range, here we must make x the subject. Please pay attention. So here, change of subject is important here. Y is equal to 5 plus 2x all divided by 3 minus 4x. The range, we have to make x the subject and equate it to something. All right? Good. So these are the steps. Please just follow the steps. You multiply through. All right? So you multiply here by 3 minus 4x. You multiply y by 3 minus 4x. So the 3 minus 4x here will cancel the denominator. All right? That is why we got this. We got the first one. Now, when you are done, we will multiply through. Okay? When we are done, we multiply y through. Good. Now we collect the same, the like terms. Then we make x the subject. Okay. Now, because we have made x the subject, then we have to make sure that the denominator here is not 0. So we equate this to 0, and we will find out all the values of y that will make this function undefined. Okay. Thank you. All right. Good. So we move on to the radical functions. We said that for a radical function, the value or the expression under the root sign, I have given you the name. I want you to remember what is the name given to the expression under the root sign. So we are saying that for a radical, the expression or the f of x, the expression under the square root must be greater or equal to 0. Okay, so this is the rule. And you make x the subject. Okay. You see that x is equal to 16. So if you put 16 here, okay, we are saying that x must be less or equal to 16. Because if I put 16 here, I'll get 0, which is defined. If I put less than 6, like 15, 4, 14, negative 20, if the value is less than 16 or equal to 16, the function will be defined. If not, the function will be undefined. So we say that x is a member of real number. X is less or equal to 16. Now, why did you do that? Look here. Why do we say x is now less or equal to 16? Because when we got here to this expression, we had negative x greater than or equal to negative 16. What do? We can divide both sides by -1 or multiply 2 by -1. And immediately we multiply or divide 2 by negative number, the operational sign is flipped. Okay. All right. Good. So we come to the absolute limit. Square root never produces negative. Please pay attention. So if there's a negative number under the square root, it's undefined. That is why we always equate it to greater than or equal to 0. Because if it is less than 0, negative numbers. Okay, so we go through this, check, and you see what is it. All right, good. So we can solve it nicely. Good. So we are saying that for all values of y is between or is from -5 to +5. It means any other thing greater than greater than 5 or less than -5, it makes it undefined. Okay, good. Why do we have two values here, -5 and +5? It's because we have 25 minus y squared is 25 minus y squared is greater or less than 0. So we take the negative y squared to the other side. We will get 25 is equal to y squared. So square root of both sides, we get plus or minus 5. Okay, plus or minus 5. So that is our expression of the domain. We are saying that every real number will make the function defined except when that number is greater than -5 and is greater than or equal to -5 and less or equal to 5. Okay, so can we see what is happening here? For f of x, we have two types of functions coming together: a rational function and a radical. Okay, the fraction here makes it a rational function, and the square root here makes it a radical. All right, good. So what do? We only prove for the root 13 minus x is greater than or equal to 0. Okay, then we can solve it. So for condition 1, the radical down here. So this is what we are saying. We equal it to greater or equal to 0. So that will give us our answer. Then we come to condition 2. Okay, good. Now what is condition 2? For condition 2, we are saying that 13 minus x should not be equal to 0. Okay, so there's it. So we have two things. We have x is less than or equal to 13. Then we have x is not equal to 13. So what do? Which one do you pick? So now our x must be less than 13. Okay, as the final synthesis. Okay, so I put this model before you, and I will need you to read through this carefully and see how best you can apply all the concepts we have learned now. Good. So we are talking about some errors you may identify. Okay, writing x greater than or equal to 16 instead of x less than or equal to 16. We just solved it. When we divided through by the negative number. But it's very important. Pay attention to it. We talk about a radical. Okay, setting up a radical. You see, for a radical, it is not equal to. Please, it must be greater or equal to. Good. And applying domain exclusion to a range answer. All right. Domain looks direct at f of x, which is you make y the subject, and the range must rearrange to make x the subject. So for range, x is the subject. X becomes the dependent, y becomes the independent. For domain, x is independent, y becomes dependent. Okay, so pause the video and go through this summary. All right, thank you so much and I'll see you in the next lesson. Bye.